All right, everybody, with the hurricane hitting and being front page story on everything, we had to get the official climate weather expert of Chuck Yates Needs a Job, Chris Martz, to come back on the podcast and explain to us what's happening. Chris, welcome back on and thanks for coming.
It's great to be here, Chuck. Thanks for the invite.
So I'm sure you and I are going to be a little bit snarky and maybe make fun of some climate stuff on this. But let's start off with this is a really big tragedy that's happened. A lot of lives have been lost and affected in a really bad way. So thoughts and prayers go out to all the folks of the Southeast that have been affected by Helene. So
Yeah, I just
the
heard that the death toll climbed over 200. So I think this is the deadliest hurricane we've had in the United States since Hurricane Katrina, and that was 19 years ago. So very unfortunate tragedy that's unfolded in the Carolinas.
Yeah. So, Chris, what happened? Because I mean, I was sitting there and somebody said, "Hey, a hurricane's going to hit." And I didn't hear anything about it. And usually we hear about things forming out in the Gulf and intensifying. This just seemed to pop out of nowhere.
Well, there was an area of just a tropical disturbance that was expected. They had the eye on it for several days. We're talking over 5 days out, and this thing was expected. It actually a week before this entire event. We were up in the weather center at my university. My meteorology majors, and the meteorologists that are on staff at our university. We were all talking about the potential for a hurricane in the Gulf of Mexico that week, and it was we were expecting it to be potentially a major hurricane because of the fact that the Gulf is obviously very warm, as it always is this time of the year. I mean, it's all even though it's warmer than average, it's warm enough in the Gulf of Mexico every year to for if all other environmental conditions are conducive for a major hurricane to form and sustain all the way up to landfall. So there was a tropical disturbance that formed, organized, deep convection, and then it began to became a hurricane, and then obviously it made landfall back on a week ago today around 11:10 p.m. And it was a category four. Now a lot of people have asked me, okay, is this? I was watching on a podcast with Daniel Horowitz on the Blaze a couple of days ago, and he asked whether or not it intensified as rapidly. It was expected to intensify as rapidly as it did. And a lot of people said it just kind of they weren't anticipating it to intensify into a category four, but actually we anticipated it to intensify earlier than it did. There was actually a bunch of dry air in the Gulf that was entraining into the circulation, and when you get dry air wrapped into a hurricane, circulation, a lot of dust and stuff, a lot of dry air. What happens is it causes the humidity to drop, and so when the humidity drops, what happens is the droplets evaporate because they're no longer in a saturated environment. And then as the droplets evaporate, evaporation is a cooling process because in order for a liquid water droplet to evaporate, you have to raise its temperature, and that means it has to take heat out of the air. So it causes the air around it to cool, and cool air is negatively buoyant. It's denser, so it sinks, and it forms downdrafts, and that suppresses convection. So it disrupts the organization and the intensification of a hurricane. So had it actually intensified earlier, which was expected, it probably would have been it could have even been a high end Cat 4 or Cat 5 at landfall versus the Category 4 with 140-mile-an-hour winds and minimum pressure of 938 millibars. Um, but to wrap up my point here, um, uh, the analogy or the about the dry air thing. This is a cool kind of a thought experiment. So obviously, when you're taking a shower, right, you're wet because the water's coming down off the shower head, and but when you get out, you start to get really cold. That's because you're no longer in that saturated environment, and so the droplets on your skin begin to evaporate, and you get cold because it's evaporative cooling. It works it's the same process that occurs just in the atmosphere on a much larger scale. That's what causes. That's why dry air actually cools the environment and weakens a hurricane, prevents it from intensifying. So had it not done that, it probably could have been worse for Florida at least than it was.
Gotcha. And so The hurricane made landfall. Normally, when we talk hurricanes, we talk Texas, Louisiana, Florida. Every once in a while, we talk kind of North Carolina. We rarely talk Tennessee when we talk about hurricanes. What caused the intensity to be maintained, I guess, as it moved inward? Or is that even a correct question?
Well, yeah, and this is another thing that people have brought up. Anytime that you have this, CNN, not CNN, CBS News, their anchor Major Garrett actually ran a headline the other night talking about how hurricanes are, and he said, pretty much word for word, he said that hurricanes are no longer landfalling events only. They cause damage hundreds upon hundreds of miles from the original point of landfall. That's obviously not true. We've seen this happen many times before. Hurricane Agnes in 1972, Hurricane Camille, 1969, and Hurricane Diane, 1955. We've even seen this with tropical storms. Um, this is not the first time this has happened. It's actually not the first time it's happened for North Carolina, which I'll get into that a little bit later when we pivot to that topic. But um, anytime that you have a tropical moisture from a hurricane and it makes landfall and it interacts with mid-latitude dynamics, such as like an upper level trough. Those lower pressure areas, when they begin to phase together and join, what happens is uh, it goes boom. It really intensifies in that baroclinically driven environment, which is sharp temperature contrast. And when you have orographics involved, which is when you have like a mountain range, and hurricanes in the northern hemisphere, they spin um, counterclockwise, which I guess from this point of view is like that. They spin uh, counterclockwise. They spin cyclonically in the northern hemisphere. So when you're talking about the geographical location, you think about North Carolina being down here, and then or Florida being down here, and the Carolinas up here. So the hurricane, the rain bands on the outer part of the circulation, as it's coming up, the circulation, the rain bands, and the eye wall, and all the moisture is being forced. These parcels of air are being forced up and over the mountain, and as it does so, the air becomes super saturated. So there's excess water vapor. That can't happen really. So it's forced to condense into liquid water droplets, and it forms clouds, and then therefore precipitation once it gets heavy enough. And there's other more complex processes that are involved there in the cloud physics. But anytime the orographic precipitation on the windward, in this case the eastern side of the Appalachians, the Blue Ridge there, Smoky, all those the mountain range there, what happens is you get the precipitation is heavy on the windward side. So we saw 15 to 20 plus inches of rain, up to 22 inches of rain within just a 2 day time period, on Friday and Saturday, and and over western North Carolina and South Carolina, parts of Georgia. But anyway, when you go to the leeward side of the mountains, of the western portion over in like Tennessee, we didn't see as much rainfall because the air starts to downslope the mountain. It dries out through adiabatic compression. So this is all just explained by synoptic meteorology. This is all explained by the basic physics of the atmosphere. This has nothing really to do with climate change. And they talk about, I mean, and this happened with Hurricane Agnes in 1972. We saw it happen all the way up. It wasn't North Carolina that was impacted as much, but it was more so Virginia, Maryland, and then Pennsylvania. There was, I think, 12 feet of floodwater in parts of Harrisburg, Pennsylvania from Hurricane Agnes in 1972. And then Hurricane Camille in 1969 caused a lot of damage. Diane, 1955. Those are just some examples off the top of my head. So this isn't, these kinds of things happen. And anytime you get mid latitude, these troughs that come down out of Canada, they swing into the United States. Uh, these troughs interact with hurricanes, tropical moisture. They tap into it, it just explodes, and it is able to create a really destructive setup. So, and a lot of times it happens. Um, it can happen unexpectedly. Although this was kind of anticipated, within a couple of days out, we were like, okay, this is going to be catastrophic flooding. Um, but this magnitude of flooding was not expected a week out. The intensity of the hurricane was well forecast, in the landfall, and the National Hurricane Center did a great job with that. But leading up to the, even 3, 4, 5 days out, we weren't really expecting this magnitude of flooding. And so when you try and warn people, um, you only give them a couple days notice. It's better than nothing, but some people are not going to take that advice. You can't evacuate everybody. Some people are just going to be stubborn, and unfortunately, it has a big loss of life. This is why we need to really improve our numerical weather prediction models in the future to be able to warn have better lead times. But hats off to the National Weather Service meteorologists at Greenville Spartanburg. They were talking about flooding potential and heavy rain uh, up to 5 days out in advance, and they had to incrementally increase their strident messaging about the danger. But again, forecasting this magnitude of flooding that far out, you can't do that. You can't go big and say, "Hey, a week from now, there's going to be a massive flood that comes through your house," because if that doesn't happen, you have a big forecast bust, and people are not going to take you seriously as a meteorologist, as a forecaster, um, in the future when you say something like this happens again. So it's kind of an iffy situation. It's a very tough situation, and meteorologists that are involved in forecasting these events, hats off to them and respect for working around the clock to try and do their best to give warning and save lives.
Yeah, we saw that in Houston because we saw the devastation with Katrina. And then I believe it was 6 weeks later, we had Rita that hit, and everybody evacuated Houston. And it turned out it didn't even hit Houston. I think it hit kind of more Lake Charles, Louisiana, Texas border. And so, but then again, everybody had seen Katrina and was scared. And so we all went to Fort Worth for the thing. So circling back to climate change, because I think that was even a question in the vice presidential debate. You know, look at the hurricane happening. This is evidence of climate change. I don't want to steal your thunder because you're the one that actually has pulled the data, and I've learned it from reading from you. But it doesn't look like when you look through the data, right, that hurricane intensity is anywhere correlated to CO2 levels. Is that
No, it's
right?
not. Yeah, that's correct. It actually has some stats here. At the vice presidential debate, which was funny because they brought up this question, and this is the climate change question. Just right off the bat, is always a question that Republicans don't tend to do as well on, even though the Democratic candidate is they're the I believe in science, and they always echo this messaging that we have 10 years left to save the planet or climate change is a crisis. Even though that's obviously not accurate, they tend to win that question over because they don't really avoid answering the question. They actually talk about, this is what scientists say. Even that's not really what scientists say. They exaggerate everything. But the Republican candidate always kind of loses on it because they focus more on energy, and that's an important topic, but it's related to climate. But they kind of just evade. We saw Trump. He's like, I want clean air, I want clean water, and 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 obviously that's important, and I agree with him. But that's kind of evading the climate question. And this is why the Trump campaign and Vance and them need to be better equipped with the facts and the stats about they can go back at the moderators and say, hey, the number of number of major hurricanes making landfall in the United States has dropped by about 50% since the 1930s. Nobody knows that statistic, but that is a fact if you look at the National Hurricane Center data. Um, but in the case of Hurricane Helene, it tied for the 21st most intense hurricane landfall with Hurricane Hazel by minimum central pressure, because lower the pressure, stronger the storm generally. It's more so the pressure gradient, but we don't really calculate that. So we just kind of go by minimum pressure. But it tied with Hurricane Hazel in 1954, which struck near Myrtle Beach as the 21st most intense hurricane struck the United States. So it's obviously since since 1851 when reliable record keeping began, we've had 308 hurricanes make landfall in the United States, 95 major hurricanes. Um, but it was so it's up there, in the upper uh, hurricanes in the top 30, but it was not even a top 20 landfall. We've had far more intense hurricanes. Now, if you look at the number of hurricanes, Florida, for example, has been hit by 110 hurricanes since 1851, 39 major hurricanes. And Florida was hit by 12 hurricanes alone in the 1870s. Just in that 10-year period, they hit by 12 hurricanes. In the 1880s and 1940s, Florida was hit by 10 hurricanes in each of those decades. And Florida was hit by 8 major hurricanes in the 1940s and 2000s. So those are the most major hurricanes in a decade. Um, and Florida also, people don't realize this, but Florida went almost 11 years without a single major hurricane, actually, without a single hurricane strike between Hurricane Wilma in 2005 and Hermine in 2016. The United States went almost 11 years without a single major hurricane strike between, again, Wilma and Harvey in 2017. Those are the longest periods on record without a major hurricane strike, and in Florida without a single hurricane strike at all, which is very impressive going back in the 175 years of data that we have. If you actually look at the number of hurricanes making landfall in the United States by year, they're slightly down. Number of major hurricanes, there's no trend at all. In 1886, there were six hurricanes that made landfall in the United States alone. This was tied in 2004, 5, and I believe 1985, if I recall correctly. There's the most hurricanes, six in one season struck the United States. Um, so it's obviously this isn't there's not an increase in trend globally. There's no increase in number of hurricanes, actually going down. 2021 we had the lowest number of hurricanes globally in the satellite records, reliable records going back to 1980, satellite record going back to 1966, record lowest hurricane count on record in 2021. um, if you look at the number of major hurricanes, there's no trend there. They're not going up or down. You can see that, and that was concluded in the studies Knutson et al. 2019 and Klotzbach et al. 2022, published in Geophysical Research Letters. Knutson et al. 2019 being published in the American Meteorological Society journals. Um, so there's really no trend in hurricanes. You can look at they were talking about, well, the rapid intensification events. And while there's been an increase in rapid intensification events in the Atlantic since 1995, which is known to be due to multi-decadal variability linked to the Atlantic multi-decadal oscillation entering its positive phase that year, and also the North Indian Ocean, which we don't really know why that is. Uh, Actually, it's gone down in the entire Pacific Basin, Northwest, Northeast, and South Pacific, and in the South Indian Ocean. So overall, globally, there's really no trend in rapid intensification events, which occurs when a tropical cyclone's maximum sustained wind speed increases by at least 30 knots or 35 miles an hour within at least 24 hours. So there's no trend globally in that, which is also concluded in several studies going back to 2003. Obviously, that's 21 years old now, but even it was recently concluded in the Klotzbach et al. 2022. And Dr. Klotzbach himself actually sent me a spreadsheet with updated data from that study up through last year. And again, since 1990, since 1980, there is no trend in rapid intensification events. So hurricanes aren't getting stronger. We're not seeing more hurricanes. We're not seeing more frequent landfalls. We're not seeing more frequent major hurricanes. It's just kind of just steady over the lot, even in spite of global warming.
And I haven't studied it to the nth degree like you have, but my understanding is tornado data is basically the same thing.
Yes, that's correct. Yeah, and actually, violent tornadoes rated EF, strong to violent tornadoes rated EF3 or F3 plus have declined by 50%, about 45 to 50% since 1954, which is when near real-time observation began in the Storm Prediction Center database on NOAA's website. Now, the disclaimer that I should put in with that data, though, is that tornadoes were typically rated inaccurately and a little too high. There was a high bias back in the early record 1950s and 60s. It wasn't until the 1970s, 1980s that we really had a consistent kind of like, okay, because they're basically rated on how much damage on their damage, which is related to wind speed, but it's related to not how much damage occurred because there's more stuff to destroy now than there was in 1954. Uh, but you look at of say there was a barn that got destroyed by a tornado. Okay, how much of the barn was destroyed? How bad is the damage? Even just from one building, you can kind of estimate what the winds were, what the wind intensity was, or the amount of tree damage. Um, so that's kind of how they're rated basically on wind. It'd be better to have wind speed data, but we don't have a very long record of that. So the data basing it off the enhanced Vegeta scale or EF scale is much better, much more accurate in terms of a long term comprehensive analysis. And the stronger, the more violent tornadoes are less easily missed because if you look at the total number of tornadoes, they go all the way up through about 1991, 92, and around the early 90s is when we had the next rad radar, the WSD WSR 88D radar come online. and became in operational use in the early 90s. And since then, the actual EF zeros, ones, twos, threes, fours, and fives have remained steady. There's actually no trend. But because of rural population growth, everybody started having cell phone cameras and stuff, or cameras, I guess, in the 90s. They didn't have iPhones, obviously, but more people spotting tornadoes, more storm reports. So the number of tornadoes, you include the weaker ones, EF zeros and ones, they increase like this, then they start to level off. So, and those weaker ones don't really last very long, and they're very easily missed. They were very easily missed back in the day, kind of like hurricanes that never passed by ships, unfortunate ships, or made landfall in the 1800s or even in the 1930s. The Hermes may have to see they weren't counted because nobody knew that they were there. But the more stronger and violent tornadoes are less easily missed because they tend to cause more damage, and they tend to be more today have longer time on the ground, causing damage. So they're not as easily missed, and that's why they've actually gone down. But even if you again keeping in mind that they were rated higher back in the day in the surveys, even since the 1970s, 1980s, if you look at the strong and violent tornadoes, there's no trend in that. It's just kind of flat. We had really bad years in 1974 and 2011 in particular. Other than that, it's just kind of just year to year variability with no clear trend.
I will push back on you slightly on Vance's answer in the debate. And, I'm a libertarian, so I always say I think they're nuts on both sides, Republicans and Democrats. But, the answer he gave, I think if you go back and say, well, the data doesn't show it, liberals will never check data. I mean, my story about liberalism is my dad had a heart attack in San Francisco 21 years ago. And this lady came up to my mom and said, "Aren't you glad that heart attack happened in San Francisco where you could get really good medical care as opposed to being back in Texas?" And my mom's just, "Houston, Texas, the home of DeBakey and Cooley, who pioneered all the heart transplants. There's more culinary, that's horrible. There's more cardiovascular talent in Houston, Texas than any other place on the planet." But this poor dear sweet lady from San Francisco was just convinced all the hicks in Texas didn't know anything about medicine. So I don't think you could get them to accept the premise that go look at the data. That's actually not true. I like the way he turned it. Oh, well, if that's the case, then we should clearly be manufacturing everything in the United States because we have the cleanest energy on the planet. And we do when you look at methane emissions and stuff. So I actually thought he was pretty effective on how he handled it, even though, to your point, the underlying science is there's no R squared between hurricanes and CO2.
Yeah, no, I agree. I mean, I think his answer, at least on the energy front of it, was great. I mean, he advocated for more nuclear power, which I was actually really, really impressed with, because it's nice to see conservatives and Republicans actually start to embrace nuclear power. I wish Democrats would embrace nuclear power and have some bipartisanship on that, and kind of jumpstart those operations. Um, my point was that, I mean, obviously, yeah, you're right. Liberals don't, the left doesn't really check the data on a lot of things. They just make claims about things that aren't true. I just find with the climate change question, when it's asked, a lot of times Trump and Vance kind of evade. My point was more so on the climate part of it, is that they kind of evade answering like, okay, is climate change happening? Is it a hoax? Is it real? I wish that they would not evade that as much, especially Trump. Um, but in the Democrats, again, they obviously exaggerate the hell out of everything, and it's just anti-science nonsense too. But they at least directly address the question that was answered in that regard. Other issues they evade on, especially the border and the economy. But I'm not going to get into that. But um, but it was nice to see Vance embrace nuclear on that point. So I think that he handled it better than Trump has, as far as the question goes. I just wish that somebody on their campaign could inform them on the state of the climate science in an unbiased manner, the way that I'm doing. I can give them the stats so that when Dana Bash or whoever asks them the question, they can say, well, actually, hurricanes have decreased. Major hurricane landfalls have decreased by 50% because had he had that statistic, boom, Kamala would have had, or Tim Walz would have not had anything to come back with that, because he's actually citing some data and statistics. Because I think if you're having a debate It's important to be well versed in facts. And Republicans succeed really well when it comes to certain issues, the border, the economy, and stuff like that. But when it comes to climate and energy, I think a lot of the right is kind of stuck on stupid when it comes to getting the facts out there. And the left is too. They exaggerate everything. They lie about things. But I wish the right needs to have be better informed on this issue to fight back against that propaganda. And I'd
Yeah,
like to see
it's
that in future debates. I'd like the Trump campaign to reach out to somebody and say, hey, get this scientist, get this person on there, and really just drill home the data on what the climate is actually telling us, what the data is actually telling us.
because I think you and I talked about this last time because I firmly believe it really, really sucks that we can't have a thoughtful conversation about this and talk about actual trade-offs because we're talking about trillions of dollars. And unfortunately, when energy prices are high, people die. I mean, and it is morally repugnant for me, the next billion people that are going to be on this planet in Southeast Asia and Africa to look at those folks and be Marie Antoinette, let them eat cake. They can do without energy because we don't want climate change. I mean, we need to be way more thoughtful about this because we ignore this at our own peril, but it's certainly not moving at the pace that Al Gore and Greta Thunberg are saying.
Yeah, absolutely. And I think that the conversation needs to really touch on, even if we suppose that climate change is this existential threat, we should, or even if it is or isn't, we should be focused on either way, we are becoming more susceptible, more vulnerable to extreme weather events. Maybe not in terms of death toll, because obviously we have warning coordination, but we are seeing increased losses, economic losses, coastal assets that are getting wiped out by storm surges, year after year. The storm surges that always happen, but there's just more stuff to destroy now than there was a century ago. Even 40 years ago, there was not as much stuff, especially along our coastlines or in the floodplains. We need to have more resilient infrastructure, better zoning, and being able to have that in order to prevent losses from occurring. So we're not focused so much on rebuilding, we're more focused on preventing them in the first place. And this is independent of climate change. The climate could remain perfectly stable through time, but if we increase our presence of our buildings, our homes, and our businesses, in tourist traps. We put them all in these coastal areas where there's going to be hurricanes inevitably every year. You're going to increase the exposure and the damage potential. You're going to increase your risk. So that turns a natural hazard that you're always facing into a natural disaster where there's catastrophic damage and potentially significant loss of life. And if we stop building stuff near the coast so much and we put stricter regulations on that, especially in up our building codes, Florida has done a really great job with that, but other states, Texas and Louisiana, Mississippi, Carolinas, they're kind of far behind Florida in that regard on the building codes and stuff. And Hurricane Harvey is a great example. Building on the floodplains there in Houston caused significant damage, and we need to be better about where we were putting. And cities in general are just putting concrete over grassland, the prairie grasses and stuff like in Houston. It can't absorb all of the water. So it's forced to you can't channel it away because you can't sink through concrete. We see this in New York City just during an afternoon thunderstorm. DC and New York City flood all the time of because of aging drainage systems. They're clogged, and these cities were not designed to handle the weather in that regard. We see flooding, especially in New York City. We see terrible flooding all the time because we're not having proper urban planning.
Yeah, and ultimately through our insurance system, that's passed on to everybody. So it's we don't just say, well, that's a Florida problem or a New York City problem. No, ultimately my insurance rates are going up as well as everybody else's. And I think that's going to be one of the big. It's starting to get a little bit of buzz now, but that's one of the big lurking giants we have is insurance rates are through the roof these days on all fronts. My car insurance was up 30%. Now, granted, I got speeding tickets like there's
Oh
no
wow.
tomorrow, but yeah, it's
Been there, done that.
yeah, it's gonna be a thing. Well, what else do we need to know about kind of the hurricane in terms of what happened and or what didn't happen?
Well, the hurricane itself, one thing that they said that I think Nora O'Donnell said on the debate, the vice president's debate, she says that climate change is making these storms larger, and they obviously what else did she say? She said larger, stronger, and deadlier. And first of all, there's no evidence whatsoever that hurricanes are becoming larger in diameter. I don't recall learning in my tropical meteorology course where carbon dioxide was a factor in hurricane diameter or radius size. I don't recall learning. I don't recall my professor going over that. I don't recall reading that in my tropical meteorology textbook that's over on my shelf. The carbon dioxide does not drive hurricane size. Some hurricanes are very small. Some of them are very big. Even if they're really intense and they're really small, they're not going to cause as much damage as maybe a weaker storm that has larger diameter because of, in the case of a much large. I mean, look at Helene; it was a very large storm. The wind field stretched out 375 miles out from its center in all directions. So, the larger the storm, you get a little bit of wind, you're going to have a big storm surge with that, and especially the shape of the coastline, the ocean shelf, and the shape of a bay, for example, is and how that water gets pushed in is going to determine, how bad a storm surge is. Um, Tampa had a pretty large storm surge with that. Thankfully, it wasn't as bad as Ian back in 2022, or Hurricane Charlie back in 2004, or the hurricane in 1848. If that occurred today, that would have been probably even worse than Hurricane Ian. Um, so. Uh, there's no conclusion on the size of a hurricane in relation to a warming climate. I mean, NOAA has talked about this. They have a hurricane and climate change fact sheet that they just came out with recently. They said that that while hurricane size and intensity and stuff and location of formation might change in the future, there's no consensus in the model projections that they have. Nuts et al. 2015, another study published in AMS, they said that there's no global scale trend in the projection of hurricane size, their radius or diameter. Um, and the other thing that she says, hurricanes becoming stronger. Obviously, that's not true. We already looked at that. And then we looked at, and she said that hurricanes are becoming deadlier. And while they're becoming costlier, which is driving up insurance, premiums and deductibles, and forcing some insurance companies to cancel plans and move out of those high risk areas. Um, the hurricanes are not becoming deadlier. In fact, the deaths have decreased by more than 75% because of avoiding coordination. I mean, the Galveston hurricane in 1900 killed 8 to 12,000 people. That's the estimate and the upper lower bounds. And that was the deadliest natural disaster in U.S. history. And obviously, we don't see 8 to 12,000 people getting killed by hurricanes anymore, even though we've had hurricanes since Galveston that have been more intense at landfall because we have better warning coordination. So they're not becoming deadlier. They're becoming more destructive, but that's not because of climate change. Um, and the insurance thing is interesting because a lot of times you'll see people, a lot of climate change activists, a lot of people on the left, they'll claim that, well, insurance rates are rising because of climate change. Insurance rates are rising, yes, and it's because of, again, what we've already talked about, increased exposure. Um, a solar farm, for example, was destroyed by a hailstorm down near Houston, Texas, back in March earlier this year. And
Down in Damon, kind of down by my
yeah,
hometown
yep,
of Richmond. Yep.
yep. The hailstorm was destroyed, caused millions of dollars in damage. If I was an insurer, I would not want to underwrite a policy to cover that because of a hailstorm. So it's not, climate change. It's just that what you're building is getting destroyed. And there's more of that. I don't want to insure things that have a high. I don't want to. It's an investment from the insurance company to cover those expenses. And
Well, and everything has a microchip embedded in it now. I mean, it used to be you got a fender bender in your car and they just pounded out the
With a
metal
hammer,
of
yeah.
your car, pounded it out, fixed it, made it look nice. Now there's a chip embedded in it that opens and closes your door, and it's $5,000. So things are
Yeah,
just more complex all
exactly. There's more
around.
technology. There's more, yeah. And that's something that's never. That's a great point that you had there, Chuck. And actually, I should probably put that in a tweet. I'll at some point, and I'll tag it because you gave me the inspiration. But, but yeah, that's a great point, and it's a there's just more technology involved. The stuff costs money, and if I'm an insurance company, I don't want to invest in paying the repair costs for that. And also, you have inflation because of that. It drives up the cost of repairs. And it's a complex issue, and people that blame climate change for that are regurgitating insurance industry propaganda as an excuse to raise rates and stuff. Because obviously, the insurance companies have to remain profitable, and there's increased risk, but some of them probably exaggerate climate risk a little bit to maximize profits, maximize their returns, as any company will try to maximize profits. But it's always funny listening to climate alarmists and people in the insurance industry, or people on the left defend the insurance industry as not having any little bit of corruption in that regard. And then they'll turn around and say that oil companies are corrupt because they want to maximize their profits. You can't have it both ways. Both there is some greed in both instances, but the prices are also set by other factors, other economic factors. It's not just money.
Well,
That's
and
just not greed. And they didn't just become greedy in 2021. You know, obviously they want to make money, but there's a lot of other things that go into determining the price of these things.
take the Milton Friedman line of, why are these human beings only greedy if they work for an oil company? Aren't the same human beings that work for the government, aren't they greedy? Isn't it
Big
greedy to
pharma.
think, yeah, big pharma? I mean, just tick on down the list of where people are quote unquote greedy. So yeah,
Yeah, it's
the
always funny listening to that.
I always love how we can collude to control oil and gas prices. And I'm like, man, if we really could, we were so shitty that one day oil price went negative. Why didn't we collude that day?
Yeah,
I might,
exactly.
I might still have a job if that was the case. Well, Chris, you were cool to come back on. Let me ask you all these questions, just because it's been wild, sort of watching the news and trying to understand all this stuff. And I love the work you're doing on X. It's good stuff, fighting the good fight.
Yeah, it's a lot of fun. It's fun to add the humor in and just go after these people that come after me. If you don't come after me and you aren't rude to me, I'm not going to be rude to you, or I'm not going to have fun with it. Yeah, if you actually ask me a serious question, I'm happy to answer it. But if you're going to be a little net zero Nancy, and then you're going to come after me and call me names, I'm going to have a little bit of fun with you. And it's fun ratioing people with facts. But at the same time, uh, while I'm having fun, I love to educate people about the data. And here's the thing: people always criticize my haters and my critics always say, "Well, Chris, you're not an expert. You're not a meteorologist yet. I get my degree in May, but I've never claimed that I'm an expert in meteorology. I have expertise in it because it's my field of study, but I didn't claim that I'm the world's top expert. I've never claimed that I know everything. I don't want people to even believe what I'm telling them. I want them to go verify for themselves. What matters to me, what speaks to me, is the data. My opinion doesn't matter, but what matters is the data, because that's how scientific evidence is. That's how scientific evidence becomes scientific fact, and because how fact is established is through actual evidence and data, not opinions. And so I don't really try to give my opinion on things. I try to present the facts and what the data shows in an unbiased manner to educate people,
Yeah, and
because it doesn't matter. It doesn't matter who is. It doesn't matter whether you're a plumber. If what you're saying is factual, that's all that matters. It's the data. It's not the person. And the climate alarmists in particular, they always attack the person, not the argument. And that's my big problem with the other side, is that when they can't defend their position, they attack the person.
Yeah, I mean, I could go the rest of my life without hearing the experts say or misinformation or whatever. It's like, come on, the way you combat this is more talking, you know?
the biggest sources of mis and disinformation are the people that are worried about the spread of mis and disinformation. The mainstream
Exactly.
media, the government, and they're not truthful. And also governments. That's always fun, is because there's the climate alarmists will come at me and they say, well, do you know more than the scientists at NASA and NOAA? Well, first of all, I know a lot of scientists at NOAA who have anonymous accounts on Twitter who follow me, and they love my stuff. NOAA has a lot of fantastic employees. I love what they do. They actually, NOAA in general, even though they're kind of, we disagree, I disagree with some of their assessment of things, they do it in an unbiased manner, and they're very good. Um, and I really enjoy the work that they put out. I used to use a lot of it to support my position. Um, but I've never said I know more than the scientists that know. But again, it comes down to the evidence. What's the data show? And also, the other point is that these people they're like they always appeal to authority. They have no. If you had actually had an argument against what I was saying, then you would provide data for that, and not just appeal to credentials or to cite to prop your argument up. If that's what you do, it's not evidence. And the experts aren't always right. I mean, look what we saw with COVID. That was a monstrosity. The experts can and sometimes are wrong, and you should never just trust government scientists. Fauci or people that the CDC, what they're saying, or what any scientific agency says, because as somebody I have family and friends who are government scientists, where they work for a different not they're not, not all of them are meteorologists, but some of them are. Some of them work in other areas as other things, and they work together on teams to come up with posters and fact sheets or social media posts or reports for their organization, their government agency. But in order, they cannot, they are told what they can and cannot say about specific scientific issues, climate change being one of them. Like, you have to message it this way. You have to say these words and these statistics. You can't talk about this. You can't talk about that. And it goes through a chain of command, through several supervisors overlook what you are writing on a before you can get it published onto a social media page or a website. And while that's important, peer review, I guess in this case, is important. Um, in the case of the government, whoever is in charge gets the final say. They get to tell whoever else, okay, yeah, you're not allowed to talk about this. You can't say that heat waves in the United States have decreased since the 1900s, but you can say that heat waves have increased since 1960 because we don't want to look at that data. That's kind of how this stuff works. And a lot of people will call you a conspiracy theorist for saying this, but scientists are under the thumb, when they work for the government especially, they're under the thumb of their supervisors, who a lot of them that run these big agencies, they're appointed, they are political appointees, and they have biases of their own because they want to use science to jog along the policy cart.
Yeah, no, and I love the point you make time and time again on your Twitter feed about maintaining your funding. If I decide to say, hey, here's what my findings are, and it goes against the narrative of the people you were just talking about, lo and behold, I lose my funding, you know? And so it always gets me that, well, the oil and gas industry funded that research or tobacco funded that research. But shouldn't you have the same disdain for the government funding the research?
Yeah, exactly.
I mean, it
It,
should
it,
be
it,
the same
it's
thing.
always fun. I made it just as out of jest. I made a climate bedwetter bingo card, and
Right.
yeah, it's like the usual talking points. Exxon knew, like they always say, Exxon knew about the dangers of global warming, and they hid the evidence, and that's always their talking point. Or 97% of experts agree, or all scientists agree, or you're a POS. That's somebody called me a POS the other day. Like that's like I'm gonna care. Uh,
The science
but
is
the
settled. I
scientists,
always
the
like
science. Oh, I
this.
didn't put that on there. Daggone it! Maybe I have to change one out. Or you watch too much Fox News, or you're a maggot. I'm like, I'm not. I don't worship Trump. He wasn't even my first choice for the primary. I'd rather have somebody that's younger and more articulate than him on the ballot right now. But you can't get what you want, right? So I'm not a MAGA cult. I have just as many problems with them as I do the far left on various issues. But your point about funding, it's actually something that's a very good point, and I've made it several times. Is that if you're going to criticize scientists who are funded for by big oil, now the fun thing is that big oil companies don't really fund climate skeptics anymore. You don't really see that stuff kind of stopped almost 20 years ago, in most cases, because companies like Shell, like Exxon, like BP, I could go on YouTube and look up a video for something, and there's always going to be an Exxon ad like we're going to build a sustainable future, and they're all invested in the renewable energy projects. They're investing in wind, they're investing in solar because they realize that they are energy companies and that they get tax breaks and stuff because they get on the good side of the greens and the left, and they get it benefits them. It hurts the smaller oil companies because they're not investing in the renewables. So green energy is actually helping the oil companies. It's not hurting them. It's the smaller companies, the oil companies that are hurting from this green energy stuff, putting them out of business. Um, and because of that, because it's a bad look for oil companies to fund climate research, they no longer do it, at least not at the scale that they have in the past. I mean, they have in the past. There are scientists but again, I don't really care who's getting funded by who, as long as the research is good. But if you want to play that game, then I'm going to tell you, well, your government funded research. I'm going to approach that with skepticism because, uh, what are the motives behind the government wanting to do this? And the whole thing with, let me find, I actually bookmarked a tweet where I talked about this, where I posted about it. You know, people will say that scientists aren't for profit, like academics at universities or government research scientists. Scientists are for profit. They want to have a career where they're able to make money and obviously support their families as anybody else. So they need to make money, and their primary way of doing that is through research grants. And scientists, their careers, whether they're in academia or the federal government, they are bankrolled by taxpayer or by government, or I should say taxpayer funded research grants. Usually apportion money that's apportioned, taxpayer money that's apportioned and put through the National Science Foundation as grants. And they also put a lot of it into research and development programs. I mean, the Biden administration actually appropriated $209.7 billion in research and development programs this year, and that cost each U.S. taxpayer about $800. And the National Science Foundation is receiving 9.3 billion of that R&D money, and a large chunk of that's is being used to fund various scientific research endeavors. And when the funding agents and now like at the National Science Foundation or whoever insurance companies that fund research or whatever, when these funding agents announce an opportunity for a research grant that you can apply for, they will state in the announcement something along the lines of, and let's just do an example. I did this on Twitter Spaces last night. Um, let's invest. We want scientists to investigate the impacts of human-caused climate change on wildfire risk in Mediterranean California. So that's the announcement of opportunity. That's what they want. Um, they want some scientists to apply for that research and figure it out for them. How is climate change impacting wildfire activity in Mediterranean California, and how will carbon dioxide emissions reducing them to net zero by say 2050? How is that going to influence fire risk in the future? How is that going to reduce fire risk? So these research grants, they have very specific set of guidelines that applicants must adhere to. To apply, a scientist has to submit his or her research proposal, and that includes outlining your research goals. So basically, adhering to their 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 um, their requirements. You also have to discuss the methods that you're going to probably use to investigate the problem outlined in the research grant. You're going to have to specify a budget. How much money are you looking to spend, or how much money are you wanting so that you can spend conducting this research for, say, travel or for equipment or whatnot, technology. You also need to discuss in your proposal when you submit it for application to get the grant, how is my research potentially going to be beneficial to the scientific community and the overall contribution to the body of knowledge? Um, so, an example that I just discussed about wildfire risk and climate change, if you submit a proposal and you say, "Well, I don't really think human-caused climate change is the primary factor for increased fire risk in California in recent decades," And you think that rather the risk could be reduced significantly through better forest management, practices such as prescribed burning, mechanical thinning, um, or maybe placing power lines underground, so they don't topple over during high wind events, such as this, when they get the Santa Ana downslope winds, or maybe having stricter zoning codes to reduce fire risk. If you submit that in your proposal, you want to focus on those issues about how, again, forest management and the placement of power lines, and zoning regulations. How if you want to focus on that versus CO2 emissions, and you just put that in your proposal and you want to investigate that, well, you're probably not going to get funded. They're probably going to say, nah, that's not what we're looking for. You're not getting the research grant. But even if you do happen to get the grant, it's unlikely that paper will pass through peer review, because journals like Nature, Science Magazine, they have very specific, they have the journal editors have a specific storyline that they kind of want papers to adhere to. Climate research now largely focuses on um, climate change impacts and why this is a bad thing versus, you know, climate dynamics, understanding what's really going on. And now, if you, on the contrary, if you adhere to the guidelines and you that are laid out by the funding agency, you will most likely be funded and published in that journal. If you say, well, yeah, I think carbon dioxide emissions from our burning of fossil fuels is increasing fire risk in California, and if we reduce emissions to net zero by 2050, well, we'll have reduced fire. If you say that, probably get funded. That's how it works.
No, that's exactly right. I always say this whenever people talk about the experts and all that. The greatest scientist, maybe the greatest scientist who ever lived, but certainly the greatest scientist of the 20th century, that would have been your defense. My expert's a postal clerk, Albert Einstein, right? And he would have been ridiculed just on the basis of that. And dude changed the world. So yeah, it doesn't matter the source. So create something where you can forecast, predict, and if it comes true each time, yes, we've proved something. Scientific method has served us well. It's too bad we still don't use it.
Yeah, scientific method has become the scientific worshippers method. That's what it is.
Exactly.
It's circular reasoning. You start with a predetermined conclusion, and you work backwards to try and find data that fit that narrative.
Exactly. Well, Chris, you were cool to come back on. I appreciate it. Standing invite. We got to get you down to Houston at some point.
Well, I might be down there in January. We got a conference in New Orleans in early mid-January, and me and some buddies might take a day trip to Texas. So
there you
I'll
go.
let you know.
We're happy to host, man. Thanks again, dude.